So today we're going to be talking about this question, but in particular, because we have done a video on this question itself, we're going to be talking about how could we get students to answer this question, because it's not a question that they would see every day at all, but it practices some great skills and it gets them really thinking about how lowest common multiples work. And so we're going to talk about how we might get students to a point where they could answer this question. To do that, we're going to build like a little worksheet that hopefully gets them to something similar. So let's start by answering the question. So we can do this in two ways. The first way is from top to bottom, top to bottom. So we start with the number 10. We think, okay, 10 is a multiple of 10, and 1, and 2, and 5. So we've already ticked all those things off. Then we go down and we think, okay, it's not a multiple of 9. So to make it a multiple of 9, I'm going to need to times it by 9. Because now 90 is the lowest common multiple of 10 and 9, and 5, 2, and 1. And actually, there's something else there. 9 times 10 is also a multiple of 3, because 90 divided by 3 is 30, so 3 is a factor of 90. It's also a multiple of 6, because you can see in 10 times 9, that can be written as 5 times 2 times 3 times 3. And look, in here hidden is a 6. 6 is a factor of 90, and so 10 times 9 already gives you 1, a 2, a 3, a 5, a 6, and a 9. So now we need to make it somehow also be a multiple of 8. Now to do that, we don't need to times it by 8, because we already have a 2 in here. So we actually only need to times it by 4. Because now this number, 10 times 9 times 4, will include a 4 times 2, which will give me that 8 that I need. So that's done. And look, now this is also going to be a multiple of 4, because clearly it's got a 4 in it. So now the last piece missing is just this 7. So we just need to times it by 7. So my answer is just 10 times 9 times 4 times 7. That will give me the lowest common multiple of all these numbers. And that number is, let me just do it on my phone calculator, 10 times 9 times 4 times 7 is 2,520. How nice is that? Now the other way to do it is from bottom to top, which just means starting at the smallest numbers and working upwards. So all numbers are multiples of 1, but let's start with 1. To make it a multiple of 2, I can just times it by 2. To make it a multiple of 3, I just times it by 3. Now to make this a multiple of 4, well, we already have a factor of 2 here. We just need to times it by 1 more 2. And now this number is a multiple of 4. In fact, let's change colour. So we've ticked off 1, 2, and 4, and 3 there. Now to make it a multiple of 5, we just need to times it by 5. Tick that off. Is it already a multiple of 6? Yes, it is, because it's got a 3 times 2 in it. It needs to be times by 7 to make it a multiple of 7. Is it a multiple of 8? Well, it's only got 2 2's in it. We need another 2, because then it has a 2 times 2 times 2, which is 8 inside it. So then it's a multiple of 8. To make it a multiple of 9, well, we've only got one factor of 3 in it. We need another one to get it to 9. And is it already a factor of 10? Sorry, a multiple of 10? Yes, it is. It's already got a 2 times 5 inside it. So this number, 2 times 3 times 2 times 5 times 7 times 2 times 3, is also 2, 5, 2, 0. And that is the lowest common multiple of all those numbers. What a great question. So lovely. So what we're going to do is we're going to talk about how could we get students to do that. Now the way I would place this in like a scheme of work or in a section of lessons is we would have already done simple lowest common multiples. They'll know how to find the lowest common multiple of 2 numbers. So what we can do is find the lowest common multiple of, and actually let's just call it LCM of. And now let's just do lots of questions. And what we're hoping for is that each of these questions will spark some connection between each one. So let's see what we mean. So let's start with the LCM of, how about something easy? 1 and 2. 1 and 2. Now what that can get us to do, and I'll unitalicize it at the end, what that can get us to do is just think, okay, everything, the 1 is irrelevant for that. So the next thing I can do And let's do this again. In fact, what I could do nicely is just copy this. So how about 1, 2, and 3? So once again, we're ignoring the 1 basically, but we're thinking about what change does the 3 have. And just, why don't we also do this? Now this is actually the same as the one above. We've shown that the order between them doesn't matter. Now, another interesting thing could be, how about the LCM of 2 and 4? How about 2 and 4? Because then what's different, if you think about it, is instead of just multiplying 2 and 3 together, here, 8 wouldn't be the answer. The lowest common multiple of 2 and 4 would not be 8, it would just be 4. So, how about now we do 2, 4, and 3. 2, 4, and 3. Because here we're seeing, we don't do 2 times 4 times 3, we think about what we got for the previous one, and now we're just timesing it by 3. And actually, what might be a nice next step? How about we do 2, 3, 4, and 5. So we're thinking, how do we get from the one before to the one to this one? What could be a nice next one from 2, 3, 4, and 5? Maybe 6, because that's 2 and 3, and 10. Let's see this one, because this one actually is the same as the one above, or is it? No, it's not. You actually get 30 from this one, but it's similar to the one above because you see the 2, the 3, the 2, and the 5. So you think maybe it's the same. What's different? So the lowest common multiple of 2, 3, 4, and 5 is going to be 6 times 2, which is 6 times 2, which is 12 times 5, which is 60. But 6 and 10 is 30. Oh, because 30 doesn't divide by 4. Ah, so that's what's interesting about it. So this one works because it's 60. It's not the same as the one above, even though 2 times 3 and 2 times 5. Okay, that's nice. How about we do 4, 6, and 10? Now it has to be a multiple of 4 as well, so it can't be 30. In fact, what we want in between here is we want some examples. We want the teacher to be able to go through some examples. So we probably want them to be able to go through how about the LCM of 4 and 12. So we'll just get a few examples in for students to do, or for a teacher to go through. And actually what's nice is you can go through this by breaking them apart. That's what's nice to practice here, is that you can answer this by saying, okay, well 4 is 2 times 2, and to make that also a multiple of 12, we're going to need to just times it by 3, because then we get straight to 12. So this would just give me 2 times 2 times 3. Yeah, or, I mean, if you went for the bigger one first, if you start with 12, 12 is just 2 times 6, which is 2 times 3, 2 times 2 times 3. And then all you need to do is just check, what is this also a multiple of? Well, it's also a multiple of 4, which is nice. Okay, so that's one example that we might want to use. We also might want one with 3, 4, 12, and 20. Now, for this one, we've already done 4 and 12, so we can actually start with that. But if we start with the 20, we know that 20, and you can do product of prime factors here, which is what's a nice skill you can practice. 20 is 2 times 2 times 5. So that's what we can start with. We go 2 times 2 times 5. This is already a multiple of 4. That's already a 4. So to make a multiple of 12, we just need to times it by 3. So it's just 2 times 2 times 5 times 3, which is so nice. That just gets us straight to the answer. So this one would end up being 4 times 3 times 5, which is 60. How nice is that? So just a couple of examples, and I would always, these ones are nice to work from top down, but also you could have answered them from bottom up, which means using the lower ones first. So for example, let me just get rid of that, actually, whatever. I can rub those out. So we could have done 4 is 2 times 2 to get it to 12, which needs to times by 3 to get it to 20, which needs to times by 5. How nice is that? These questions are so lovely, and they really get you to think about what makes multiples. So let's keep going with some more examples. 4, 6, and 10. How about we copy this? We do 4, 6, and 20, so we can see what's changed. Because actually, nothing has changed here, because we already have a 2 in here. This is going to have the same lowest common multiple as this. How about we do another one? And how about we see 4, 6, and 40? Because this one's going to be different. And then let's go back to our building up from the bottom. So let's go lowest common multiple. Oh, no. Lowest common multiple of, in fact, let's just quickly change the spacing. Okay, cool. So now let's just go back to the 2, 3, 4, 5, and let's just add a 6 in. So 2, 3, 4, 5, 6. And now what's nice is we can just go step by step. We can just add a 7, 7, an 8, and a 9, and a 10. And then we're actually done. We've got straight to answering that question. Let's see what other scaffolding we might want to include. Okay, so now that's all formatted nicely, let's see what other questions we might want to include. For example, we could think of how could we make this number a multiple of 6? So this is an interesting question, because why don't we get a number that's a multiple of 2, 5 and 6. Why do you 2 times 5 times 7? Why do we do 70? Now the reason this is an interesting question is we don't just need to times it to make it also a multiple of 6. Okay, so we could, okay, this is nice, because we could times it by 6. That's guaranteed to make it a multiple of 6. But we could also talk about the fact that this is 7 times 10, which is 2 times 5. So that's 7 times 2 times 5. Now we already have a 2 in here. So to make a multiple of 6, we only need to times it by 3. Because now it is going to be a factor of 6, because it contains a 6. It can be divisible by 6. So actually all we'd have to do is times it by 3, which would make it 210, which is a multiple of 6. So that's actually a really nice question. Okay, now let's look at some extensions. So we've got to answer our question itself. Easy extensions is, what's the LCM of all the integers from 1 to 15, or 1 to 11, and then we could do 1 to 12, and so on. And actually what's really nice about these is we can really think what's actually going to change. So for example, is the LCM of 1 to 15 different to the LCM of 1 to 16? For example, does the lowest common multiple of 1 to 15 also contain a factor of 16? Because then how about 1 to 17? Because that'll be interesting, because then we get a prime. So you can say, what do you notice? Okay, so what we've really done here is we've started with this great question, get kids to think about it. I would suggest actually, if you're doing this in a lesson, I wouldn't go through it now. I've just talking about how you might go through it. I would start with some smaller examples here. Then think of how we can make this a multiple of 6, breaking it down and then multiplying it. Then get students to do these questions, then look at some extensions. And great, there you have a lovely 1 hour lesson, for example, where you're getting to rethink deeply about lowest common multiples, using the language of factors, things like that, and also doing some prime decomposition for questions like this. So there we go. Let me know if you would have done anything different, what other questions you might add, any other extensions you can think of in the comments below. Thanks for watching. Okay, so this is actually Natan from a bit in the future, just because I added some other questions to the lesson that I thought actually would be really nice. For example, this one on the screen, which numbers can this number be divided by? Now I put this like right at the beginning, because then you can really get kids to talk. This could be a nice starter, actually. In fact, yeah, this could be a really nice starter, because obvious ones like 2, 5, 8, 9, and 11, but then also things like 10 and 40 and 72 and 99, and there are so many ways that you can have so many numbers that this can be divided by, and then you can talk about how all those everything you've just done means that this number here, 2 times 5 times 8 times 9 times 11, is a multiple of those numbers, and that's a really nice way to set up the later stuff we're doing. I also added this, where we're thinking about, are the following numbers divisible by 12? And how would you know? So the first one is obvious, but this one is less obvious, and then less obvious, and less obvious. And this last one we can talk about, well, you could divide it by 12, or you could do prime factor decomposition to break it apart and see that you can get a 12, which is really nice. Then, how could you make the multiple of 24? So for the first one you wouldn't have to, but for the second one you'd have to multiply it by 2, stuff like that. Thought it was really interesting. Similarly, what would you multiply these numbers by to make the multiples of 15? Not 12, so then we're thinking about 5s, just adding questions to get kids to think deeply about how these are multiples of different numbers. Do we add anything else? No. So it's just really some more stuff at the beginning to talk about divisibility and knowing which numbers are multiples of which numbers. And really there are so many ways you can go with this. So let me know in the comments below. Thanks for watching.